Okay, so when you first look at these graphs, the first thing I would suggest that you do, a highlighter is kind of helpful with these actually. I'm going to use my highlighter every time. I would advise you that these graphs, if you notice, do not have a C. Okay, the equations that you're going to be writing is not going to involve finding a C, which means there is no phase shift, which means these are graphs that start at the y-axis. Okay, so if you can figure out, just highlight the y-axis, and then the next thing to highlight is the midline. Okay, where's the midline of this curve? -2 down here, right? So my advice is that you kind of divide the graph up like that, because this is now the center of our graph, right? And then the next thing to do is figure out where the period ends. Okay, this curve starts right there. Okay, I'm going to trace this curve, and you guys got to tell me when I should stop, when I've reached the end of exactly one cycle of the curve. So if I'm at a maximum, okay, then where I should stop is right there, right? At a maximum again. All right, and what that does for me is this. It allows me to divide this graph up. This is my graph right here, okay? It begins at 0 right here. It ends at 2 pi right there, okay? Is it a sine or a cosine? If it's got a maximum at the beginning and a maximum at the end, it's a cosine. Is it positive or negative cosine? Positive cosine. So I'm going to start describing things. It's a positive cosine. What's the amplitude? What's the height of this curve? It's down. Its midline is down at -2, but the height is just from -2 up to -1, right? So its amplitude is just 1. And that's what A is going to be, is 1. All right. What is the vertical shift? It's scooted down how far? Right? It's scooted down to -2, isn't it? So the vertical shift is -2, and that's what D should be. And then the only thing left to find is B, and that has to do with the period, right? All right, the period should be equal to 2 pi over B. What is the period of this cosine curve? 2 pi, right? We mapped it out, and we said the exact width of that was from 0 to 2 pi, from here to here. So its period is 2 pi. So set 2 pi equal to 2 pi over B. And what is B? Right, this one's not difficult. Some of these will be much more difficult than this. Okay, this one, you could do the cross products thing, or you could just say B is 1. I mean, you can see in that equation, okay, technically, you could say 2 pi times B equals 2 pi, B equals 1. All right, to write these equations, you need to know if it's positive or negative, sine or cosine, and you need to know A, B, and D, and we know all of those things, and so now we can write the equation. All right, y is equal to a positive 1 times the cosine of B times x, so 1x, and then close that parenthesis so that D is a -2. So you can write that if you have all those numbers in there. What's the simplest way I could say this? Y equals the cosine of x -2. I don't care which way you say it. If you want to put those ones in there and those parentheses, that's fine. Okay? I think this is the equation. Is there a way for me to verify that the equation I wrote matches the graph? Okay, yep. Okay, choose points that the graph goes through. It goes through 0, -1. And then, again, don't choose the one way out at the end. Go to the mid, go to the next point right there. What's that coordinate? Right here. It's to the right, pi over 2, and down -2. So pi over 2, -2. Remember, those are x and y. So if you're in radian mode, you should be able to check this. The cosine of 0 minus 2 is 1, and the cosine of pi over 2 minus 2 is negative 2. And so you can check 2 points on the graph that was given and make sure they satisfy the equation you wrote, and you know you're right. So this is the same criteria that you should be able to tell me if your equation is correct or not. If it's incorrect and you can't figure out how to fix it, just mark it incorrect. All right, let's try the next one. Okay, start with your highlighter. And again, none of these have been dragged left or right. So consider that the y-axis is the middle of the graph. It's the start of a period. Okay, where is the midline going to be drawn across this curve? Looks like right there, doesn't it? Because that way it's 1, 2, 3 units above and 1, 2, 3 units below. So up at 2. Which means I have a curve that's starting right at the midline and then going up. Is it a positive or a negative sign? It's a positive sign. And then if you continue to trace it, I want to go up and then back to the midline, and then down, and then back to the midline. And that's one period, isn't it? So start finding the specs here. What's the amplitude of this sine curve? Okay, the amplitude, or B, is 3 units above the midline, right? The height of the curve is 3. I don't mean B, that's supposed to be an A, isn't it? The amplitude, A, is supposed to be 3. All right, based on the vertical shift, okay, it's been shifted up 2 units right there to the midline at positive 2, so D is 2. All right. Then we need to find B. Okay, common mistake is for people to say that B is the period. B is not the period, but the period is equal to 2 pi over B. So I'm going to write that every time. Period equals 2 pi over B. All right, according to the graph, what is the period of this particular sine curve? It was right here, wasn't it? Between 0 and pi over 2. Okay, that's the span of one cycle. So the period is pi over 2. So set pi over 2 equal to 2 pi over b. And then it's a proportion. So this time it's a little trickier to solve. Definitely when you have a fraction equal to a fraction, solving it by finding the cross products is probably a good, safe, surefire way to solve this. Pi times b, and then 2 pi times 2 gives you 4 pi equals pi times b. And so to solve for b, divide by pi on each side. And 4 is equal to b, or b is equal to 4. All right, so putting all of that together, y equals a times the sine. It's a positive a, so a positive 3 times the sine of bx, that would be 4x. No plus c to worry about. And then plus d, which is 2. So this works right here. You could have the parentheses around the 4x, although technically they're not really necessary. All right, but you want to practice checking your equation to make sure it matches the graph. So this point here would be the first one I could check, and then that one there. I You could check intercepts, like this point and this point, but I would do not the same type of thing. I would do a maximum and an intercept on the midline, or an intercept in the minimum, or something like that. So the points I see there are 0, 2, and then right. Okay, what is this right here? What is this mark right here? If this is pi over 4, this is half of that, right? This is pi over 8. So testing these, you do have to still be able to find the coordinate here. So pi over 8, the height of the curve is up at positive 5 there. So I'm going to check that. 3 times the sine, 4 times pi over 8, plus 2. I got a 1. Maybe I typed it wrong. Oh, I have a negative in front of my sine instead of a 3. That works. That works. Okay. So it checks out. So I'm not going to do any more of these. I'm going to leave the rest for you to work on. But I am going to do the initial analysis of the curve for number 3 and number 4. So let's go through just with a highlighter if you've got one, or a pen. Let's divide this up. Okay, I would start by recognizing you want to begin with the y-axis and assume that this is a curve that has not been slid left or right. So begin analyzing at the y-axis. Okay, figure out what the midline is. What's the midline of this curve going to be at? Its maximum is at negative 2. Its minimum is at negative 10. Its midline is negative 6. So it's been shifted down 6 units, and it has an amplitude of 4. Is it a sine or a cosine? Cosine, it starts at a minimum, so it's a negative cosine. But the final thing is, again, trace the curve starting at the beginning on the y-axis. Okay, where is the end of one period? Right out there at 4 pi. So you can use that to come up with your equation and test 2 points and make sure they match. Look at the next one before I leave you to practice these. The next one's really tight. Okay, it's been scrunched up quite a bit. We still, again, are starting with the y-axis. And I can see that based on the scale, it looks like it has a maximum height of 1 and a minimum down at negative 3. So where's the midline? At negative 1. The scale counts kind of funny on this one, but I can still see that it's 2 units above and then 2 units below. So the amplitude is 2 and the midline is down at minus 1. And then if I look at this curve, okay, starting on the y-axis, it looks like it's got an intercept to begin with. So is it sine or cosine? It's sine. It's going down, so that means what kind of sine? Negative sine. Okay, so it goes down, and then it's at the midline. And then it goes up, and then it's at the midline, and at that point, it's completed the entire cycle. So it has a period of 8 pi. If you can see through what I just wrote here. Out at 8 pi is where the cycle ends. So keep that strategy in mind, and then you try the rest of these. Yes. And then that's it. There's more on the back. That's all we'll do for today.